Hey everyone, let's continue with page 4 here. We're going to do some reciprocal identities now. So you can do them in the same way. Secant inverse of 2. Remember, secant is the reciprocal of cosine, right? So if secant is 2, cosine would be 1/2. So we're looking for the angle in which secant is 2 or cosine is 1/2. If I go to my unit circle, then I look for that x coordinate 1/2. There it is. And I'm getting pi over 3 or 60 degrees. So that's the answer for that one. Just be a little careful on these. Make sure you're following the interval or the range. So if I look at secant, there it is. It's essentially the same as cosine, except for pi over 2 is excluded because secant is undefined at pi over 2 and the quadrants are the same. Okay, something similar happens with sine and cosecant. Cosecant and sine, they're the same, right? Except for that 0 is being excluded, but the quadrants are the same. The one you really have to be careful about is tangent and cotangent. They are reciprocals, however, they are different as far as their intervals. For tangent, you're going to go up to 1 or 4. Cotangent, either 1 or 2. Okay, so now I've highlighted everything. We can go back to the problem. This one was pi over 3. Okay, how about arc cosecant of negative root 2, number 11? So cosecant is the reciprocal of sine. So we're really looking for sine being the 1 over root 2 negative, right? And I did that up here on number 3. Right, there's sine inverse of 1 over root 2, which is the same as root 2 over 2. So negative pi over 4, and that is in the correct range for cosecant. So I've got it. Okay. How about cotangent inverse of negative 1? You would think that would be something similar to the tangent inverse of negative 1, right, which we did on number 8. But this is where you have to be careful with that range, right? So I'm looking again, what does this mean? For number 12, the cotangent of what angle is equal to negative 1, but you have to be within quadrants 1 and 2, right? Because that's what this says up here, right? So I can't go to quadrant 4 like I do for tangent. So I know that cotangent, when it has equal to 1, that must mean you're at a 45-degree reference angle. So it's positive over here, negative here. Right? So my value is going to be there, right when x and y are equal, except 1 is negative. Right? Cotangent again is x over y. You can think of it that way. Right? So my answer for that one would be 3 pi over 4. Okay. Okay. How about sine inverse of 2? Okay. So these are, that one, I'm like, what? Sine inverse of 2. Sine of what angle is equal to 2? So I'm looking for a y coordinate on my unit circle that has 2. Well, this is a unit circle. There's no 2's, right? It's the greatest one is 1. So this one, there's just no answer. This one does not exist. That has to do with the domain. Another way to look at that, if you go up to here for sine inverse, the domain has to be between negative 1 and 1. 2 is outside of that, so there is no value. It doesn't exist. Okay, so that could pop up. About arc secant of negative 1. Okay, so arc secant is reciprocal of cosine. Where does cosine equal negative 1? Because negative 1 and the reciprocal of negative 1 is negative 1. So where does cosine equal negative 1? Right here at 180, right? Where that x value is negative 1, reciprocal of negative 1, negative 1. Should be in that same spot. Is that included in my interval for secant? Sure is. Right there it is, right there. secant pi is included, or 180. So I could answer that one as pi, or 180 degrees if you're talking degrees. Finally, how about arc cotangent of 0? Well, let's go back and take a look where we can think of that as, again, x over y is arc cotangent. So think on your unit circle where x over y is equal to 0, which means x would be 0. So I have to have an x coordinate 0, and I have to be within my 0 to pi range. So is there any x coordinates equal to 0 in this range? I see it right there. There's an x coordinate of 0 at pi over 2. So this one would equal pi over 2. Okay. You could always maybe check this. If you take the cotangent of pi over 2, does that equal 0? Right? Cotangent pi over 2, what's that equal to? That should be 0. As a double check. Okay, so arc cotangent of 0 is pi over 2, means cotangent pi over 2 is equal to 0. And there you go. Okay, it's a little technical, a little crazy, but stick with the unit circle and that little chart on the previous page, and have fun with it. Okay, those are all exact value problems. Let's turn our attention now to calculator problems here on page 5. Use a calculator to find the approximate value. Here you just have to make sure you're in the right mode typically, and then make sure you're following the correct range. Okay, so how about sine inverse of negative 0.8253 in degrees round to 4 decimal places? So I'll just bring up a calculator and we'll try it out. So if wants degrees, first thing I'm going to do is make sure my mode is in degrees. Oops, I'm in radians. So I just change that to degrees. Okay, quit. So now I'm good with degrees. And then my inverse buttons are up here. So I'm just hitting second, sine, and then putting in the value negative point. Hey, this feels like from the beginning of the semester here. So we have done these a little bit. And then there's my answer. And it said round to the nearest 4 decimal places. That's a little extreme, but that's what they want. Okay, 6189 be the answer. And that's in degrees. Looks good. Okay, arc tangent. We have an arc tangent for the next problem. It's tangent inverse, same thing. 0.5789. And that's 30 degrees. Okay, 30 point. What's that? 0.666. Okay. Fine. How about secant inverse? So the next one is secant inverse of 4.9. Remember, secant is the reciprocal of cosine. So what I'm going to do here is I'm going to do second cosine. And then inside the parentheses, I'm going to do a 1 divided by 4.9003. Okay, so that's your tricky little shortcut, because you don't have a secant inverse button unless you have a super cool calculator that has that, but most don't. Right. But I'm good to go. I got 78.2250 if I round correctly to 4 decimals. All right, and I've got it. Okay, so that's 16, 17, and 18 on the handout. The next one is arc cosine of negative 0.5, and number 19 wants you to find the approximate value in radians. All right, so we're going to change the mode. Arrows. All right, got an radian mode, and then quit. and keep on going. Now I'm cruising here, cosine inverse, negative 0.5. And it says round to 4 decimal places again. So this one is 2.0944. Okay. Okay, all is good, except for now we get to cotangent inverse. And the cotangent ones are the worst because of the interval for the range. So when I do cotangent inverse of that value, if it's positive, you're fine, it'll just work out. But the negative ones, we have to do a little adjustment. So let's try this out. The first step, okay, so we're trying to find cotangent inverse of negative 1.668. What I'm going to first do is find tangent inverse of 1 over that. Okay. So I'm doing tan inverse negative 1 divided by 1.668. Okay. See what that is. So that's a negative 0.5401. All right. And oh man, I sure do wish that was the answer and I could be done, but unfortunately that's not within the range of the cotangent function. You should be in quadrant 2, right? This is a negative value, which is in quadrant 4. Okay. So a quick fix for that. Think of this as a little reference angle, ignore the negative. Your reference angle is 0.54 radians, and you want to be in quadrant 2. So that's going to be pi minus that value. So then to get my answer, I've got to do pi. So I got my pi button minus, and then I'm going to do that value, 0.5400, whatever. Just keep on going here. And then do the final rounding after I get that. Okay, and there should be your final answer. So that one's going to be 2.6015. All right. So cotangent, the negative cotangent ones are the worst. You got to do that pi minus thing after you get it, and then you're good. Okay, how about the next one, cosecant inverse of 0.952. Cosecant is the reciprocal of sine. So I'm going to do sine inverse 1 divided by 0.952. And that gives me an error. You ever get that? Now, did I type something in wrong, or is that telling me something? And in this case, it's telling you something. If you think about that problem, 1 divided by 0.952 is actually larger than 1. So you're outside of that domain. So that is a correct response here. The error is the domain, right? So this is another one that does not exist. Okay, so if I jump back to my handout and explain that a little bit more, and then we'll take a break. How do I get back to my handout? Where is it? So this one here, right? I'm looking at that value, cosecant inverse of that value. If I go back to my little handy table up here, cosecant inverse is right there. Here's your domain. Values that you input into that function have to be greater than 1 or less than -1. So not between -1 and 1, which we have a value here, right? So that's why it doesn't exist. That value is not in the domain of the function. Okay, so it does not exist. Okay, I know I'm stopping in the middle of pages, but that's just a good breaking point. The last video, I'll finish out the last few problems and send questions my way if you have any. Hope all is well out there. Talk to you later.